think we're good. Oh no. Okay. Well, that's what you get for using Linux, I guess. Oh no, no. Right, packed house. This is probably the biggest audience I've spoken to. But yeah, thank you all for coming. Very excited to be here. So today I'll talk about how I've been using Golang for the past 1 year or so for automating various operational tasks. The journey sort of started when I was in my previous job, where which was also my full-time DevOps role, whatever that means. Instead of trying to string together various OS-specific commands and programs to solve my problem, I started using a programming language. I was also working on like a mixed operating system environment like Linux and Windows, so some of the solutions really needed to work on both, and I did not want to write different solutions for each operating system. So which programming language did I use? Well, considering that I'm speaking about this in a Golang meetup, it turned out to be Golang. So our agenda today is as follows. We'll talk about the why. Why would you want to use Golang for your scripts? A script can mean different things to different people. It can mean like 5 lines, or it can be 50 lines. We'll talk about some recipes and pointers, with no pun intended. And then I'll talk a bit about Golang for automation at Cover Genius. So the kind of recipes we'll discuss will solve like a specific problem, and hopefully the ideas that you discuss there will be generally applicable to whatever use cases you'd have. I'll share the standard library packages and the third-party modules that I have used. And hopefully there won't be a case of not invented here syndrome, where my Google search didn't result in the right solution. I ended up writing it myself. So just before we go into the why, a little bit about me. I'm a DevOps engineer at Cover Genius, who, as you can see, is about smarter insurance. I encourage you to check out covergenius.com to learn more about what we do. I am also the author of this book called Doing Math with Python. Been out for a few years now, apparently doing pretty well since I keep getting the royalties, so happy to say that. But otherwise, I have been around sort of a while in like various communities around Golang and Python. Over the years, I have become very passionate about developer tooling experience, logging, monitoring, and basically anything not to do with feature development of products that pay my salary. So anything beyond that is my area of interest. So all right, let's get started. So why Golang? So this is a curl like snippet with using curl and various other bash commands. Too much to even talk about, and these are the kind of things. First of all, I can't even write them from memory. That's the first thing. Second thing is, even if I have written them, I will by writing I mean copied and pasted them. It's harder for me to reason about. Yeah, maybe I'm just dense and whatever. But this is a classic case of things which I want to avoid, or I wanted to avoid as I started up on this journey of switching to Golang for writing scripts. Obviously, using Golang hasn't exactly been easy. Lots of frantic searching. It even involved switching from DuckDuckGo to Google because DuckDuckGo wasn't good enough, especially when I wanted the solution really fast. But a commitment to keep at it has worked so far. Pleased to say, I think now I can start. I can actually start writing a Go program without having to, Google. So that's a good start. So yeah, basically I wasn't writing any Golang before 1.5 years. Essentially, I was aware of it. I wanted to learn it, but I wasn't really any good at it. But now at least I can start off, writing programs. So, and that brings to my, I guess, reason number one, which is like a very personal reason, which is to, just learn Golang. As part of my job, there's a lot of, automation, automatable, tasks, so to say, that we do every day. And, just first of all, doing them manually is, it's just a waste of time. Doesn't sound right, can become very error prone. And And yeah, just to automate is a good idea, and then using Golang is a better idea, I feel. And of course, and when I mean job security, I mean current job security, which is I want to write Golang so that they keep me, so that they don't have to hire Go engineers. And second thing is, like I decide to move on, I can say, I know Golang, so it's like a street cred or something. The reason number two is basically like a host of reasons, which is what I call the usual Golang features, which is static multi-operating system binaries, which makes distribution really painless, especially when I'm writing the tools for other people to use, like our developers, in terms of developer tooling. The compiled and build cycle means I have some guarantee of the code not breaking where I don't expect it to break. I mean, it can break, but at least there's some guarantee of it. And then, of course, the usual Golang concurrency primitives like goroutines and channels if I absolutely need to do that. And the third reason, again, is just the third-party packages, the ecosystem around it, lots of infrastructure code that's being written in Golang, like APIs for the SDKs for the APIs are easily available, like AWS, Cloudflare, or probably anything that you would work with these days. There's a good chance it's written in Golang. So it's a great source of inspiration, which sometimes can be a good copy pasting scenario as well. And then in addition, we have this CLI frameworks like a couple which I'll discuss later on. So it just feels like there is just a host of support around the ecosystem that has developed around Golang in the last few years that really makes it very suitable for this operational task or any kind of automation that we may have. And that brings to my Zen of DevOps scripting, so which is shell scripts are better than nodes, Python Ruby is better than shell script, and Golang is better than Python or Ruby. I don't have to do a lot of convincing here. I'm sure everybody will just adopt this from tomorrow. So which brings to my 0th recipe, and that is how you can get started. Like, let's say you haven't written a single line of Golang code before this, and so yeah, download and install Golang 1.13 plus, which is the latest version right now. Basically create a directory, do a Go mod in it, which is basically initializing a Go module, and which is current sort of the de facto proposed mechanism for sort of using third-party packages. So you don't need it. You don't need the Go module if you're just using only the standard library, but eventually you will probably need to. So it's not a bad idea. You may also need to use you also need to use a Go module if you are trying to redistribute your program or as a package which you want other people to use. So yeah, and then Go build, and all you're set. So like I said, the journey isn't exactly very straightforward if you're just getting started. So yeah, definitely learn about Golang modules. There's a website called gobyexample.com, golangcode.com. There's other links, and then of course Google. So usually my trick is Golang. I prefix every query with Golang, and that usually will give me to the exact Stack Overflow question and answer, which I can copy and paste. So all right, let's talk about real recipes. So this is a problem which was actually probably the first problem which I was faced with, where I needed a solution which needed to work on both Windows Server and Linux, and it needed to be run at EC2 bootstrap time. So the problem was that we are using so this is AWS specific. We are using this private hosted zones, which means we had few DNS addresses which were only resolvable within the AWS VPC. And we're using Docker, and we needed to basically add this additional DNS server, which is a VPC specific DNS server, into the Docker configuration. And so we needed the solution which had to work on both operating systems and distributed so that it's available at EC2 bootstrap time. So I used Golang to do it. I built the binary for each operating system, which is pretty easy, using Go OS flag, and then just put it on the EC2 AMIs and just called it in the user data script. So just to give a so that we are on the same page. So for example, if let's say 10.0.0.016 is your network, the DNS server for the VPC is at 10.0.0.2. So essentially, at runtime, basically what you need to do is from within the EC2 instance, you query the AWS metadata, figure out the VPC CIDR, and then perform a bit of IP address arithmetic, and that gives your DNS server address. So let's see how we can do it using Golang. So the first line, so I have tried to adapt a convention here. I'm not sure how much I have followed it. The green bit is the Golang function that I'm using, and everything else is in white and some other color. So the first bit here, which is to find the VPC CIDR block, is to make a HTTP GET request to this AWS metadata URL. And so that's the first line, which is what you're doing. So HTTP is the net/HTTP package. So the GET function is used to make like HTTP GET request. It returns us two return what should we call it? Return values. So the first is a HTTP response object, which is RES here, and ERR is the error. Now, obviously, you should do error handling. We're not doing it here. So the second line, what we're doing is we're just reading the response body using the ioutil.readAll function. Now, this may not be the most optimal way to read the body of HTTP response in different scenarios, but in this case, because the body itself is just consists of the IP address, it's just fine. So ioutil is like a bunch of it's a package which encapsulates a bunch of helper methods for IO. So this function returns us two values. The first value is it's a byte array, I think. Yeah, it's a byte array, and ER is the error. And then what we do is we basically use the formats package sprintf sprintf function to construct this other URL, which is the AWS metadata URL for obtaining the VPC IPv4 CIDR block. And once you have constructed this URL, we again make a HTTP GET request to get the value to get the response, and then eventually we again use the readAll method to read the VPC CIDR and put it in this variable. So the next bit here is doing the IP address arithmetic. So we use a fair number of standard library functions here. So the first function that we use is the parse CIDR. So essentially, as is probably implied, it reads like a CIDR block, and it gives us back the IP address of the CIDR, the network address bit of the CIDR, and then there's an error value. So at this stage, we have now got the IPv4 address. And then, so the next step that we need to do is we need to perform the IP, address arithmetic. So we use this function called, we use this package called the binary package, which has this big endian type, to essentially convert this IPv4 address into unsigned integer. So this is one of the, as a detour, I'll mention that while I was trying to just, basically go through and understand this bit properly, like how we are doing this sort of conversion and all that, it sort of was a very good refresher into big endianness and the order of bytes and network byte order. So it forced me to just look into those things, and in the process just end up learning a bit more about what's going on. Anyway, so we have the unsigned integer in IPv4 uint variable, and then what we do is we just add 2 to it. And then what we do is we do the reverse conversion, which is we convert an unsigned integer into a byte array, which is essentially, and then we use that. Now you can see that buff here is basically a byte, so net.ip is like a type, which is basically a byte array. So that's why I refer to it as a byte array. So in this buff variable now, we will have the DNS server address. I've got this Golang playground link here, which sort of has a bit more annotation into the IP address arithmetic here. But that's it. That gives us the DNS server address. So the key packages that I used here was FMT, which is the format sort of functions, net HTTP, net encoding binary, and then IO util. So this is actually like a proper binary, like a package which I have uploaded to GitHub. So this actually is a working solution, so you can explore it. All right, recipe number 2. So in this recipe, we'll see an example of how we can make HTTP post request to the JSON body. We'll also want to read the JSON response back and be able to access response objects. Now, arguably this takes a lot of code to do, as you will see. You might want to say, you could just use curl and JQ, but that's not the question we are trying to answer here. We are convinced that Golang is the right way to go about our scripts. So there are 3 things here that we'll see. Make a HTTP post request. Because our server is using a self-assigned certificate, shouldn't be certification. We'll see how we can use like a custom HTTP client. And then the response will be JSON format, which we'll read back and see how we can process in Golang. So the first bit is making the HTTP post request. So the first thing we do here is construct the JSON body. This is where you can start questioning your decisions about using Golang. But everything has its pros and cons. So this is how you do it. So let's say your JSON body needs to have like a single object, user ID, and it needs to have an integer. So the first bit we do here is construct a map or a dictionary, however you want to call it. Basically the key here is a string and the value here is an int, and we are initializing it with this particular key called user ID and value, which is an ID. The next bit that we do here is use the JSON package to marshal these values into basically constructing the JSON body, using the marshal function. Now, the underscore you see here is basically Golang's way of ignoring a value. Like, let's say if you don't want to do anything with that, you would just put an underscore. Ideally, you should do something with it. It's an error, so you should handle it. But the next bit here is how we can parse like an URL. So Grafana URL is a variable. So this code snippet is from one of the internal tools that we are using to back up our Grafana instances. So that's why we have this Grafana URL string. So that's a string which contains a URL, and we use this URL.parse function to basically parse the URL. And the reason we do that is because we need to perform some sort of like a path join on the URL, because we wanted to append some variable to it. So the way we do it is path.join, and then we give it the path, which is what we passed before, and then we give it the string which we want to join to it. So our URL is constructed now. Then what you have is, in the previous recipe we saw a shortcut way of doing a HTTP GET request. For a post request, but there's another way of constructing HTTP requests, which is using the new request function. So here we are constructing a post request, which is the first argument, which is a method type. The second argument is the URL itself, where we use the string string function to get the URL that we constructed in the previous step. And then we construct a buffer object from the JSON bytes that we had marshaled earlier. Now, there's a lot of terminologies which I threw in there, like buffer objects and bytes and all that. Yeah, it will take a while to get used to those. I haven't yet got used to those, but I'm getting by. So, so I've constructed this new request, essentially saying that okay, with this URL and this is the body that I want to send it. But I also need to send the content type header. This is how we set up a content type header using the header object and calling the set function on it. Now, I talked about using path.join here to join URLs and construct URLs. But better method would be to use this other function called resolve reference. So I encourage you to check that out instead. Okay, so at this stage we have constructed the HTTP request, we have specified the payload, we have specified the content type. So the next bit is constructing the custom HTTP client. Now here I'm skipping TLS verification because obviously it's the right thing to do. So this is how an example of how you do it. So we construct this transport. So we create an object of type HTTP transport, which is a structure. We basically say insecure skip verify and just skip it. So this is like our custom transport that we have created, and then we create a HTTP.client object specifying the transport that we just created previously, and then we call this do function on the client object with the request. So REQ is the request that we constructed here, and the next statement, which is a defer. Essentially, this is goal. If you're not familiar with it, this is essentially a defer is a way of ensuring a function gets called before your current function returns, essentially. So this is essentially here we are saying that the response body should be closed. We don't want to leave it open. So that happens only when the function is returned, when the call returns from this function. And then the last line is how we read the response, using the resp.body object. So we have now read the response, but there are still bytes. We haven't really serialized them. We don't know if they are valid JSON either. So the next step is to basically use the unmarshal function to basically convert the JSON response to a Golang struct. So again, here we have to say what is the type of object we are trying to unmarshal this JSON body into. So here it's a struct which has two fields in it, which is an org ID, which is an integer, team ID, which is another integer. The JSON here, these are called structure tags. This is basically a way of saying that in the JSON format, this field will be called org ID, and team ID will be called team ID with a small t, whereas in my Golang struct it will be org ID and team ID with a capital O and T. So we call the unmarshal method. So the first argument to it is the body itself, which is what we read using IOUTL, the read all. And then we have the object which we want to serialize into. And it returns only one value, which is the error. So if it unmarshals successfully, you don't get an error. Otherwise, it does. So after this step, you will be able to say, from this point on, you will be able to access the team members result variable to access the data that you just read into. So just a recap of the key packages. So net URL, net HTTP, IO, IOUTL, encoding JSON. When you're working with HTTP responses, there are two things I really found useful. Actually, the second one is the one I have been using a lot. It basically, you give it this JSON object, and it automatically converts it to like a Golang struct, which really found tremendously useful because it can become very a chore to basically write those structures yourself. The second project by the same author, I think, tries to do away with that. I haven't actually used it, just my colleague sort of shared it with me. So it's worth checking those out. All right, third recipe. So this comes from sort of use case I had where I only wanted to run a certain script, and so that there's only one copy of it running at any given point of time across all my CI jobs. Now, at this stage, we're running like a single CI node, so I didn't really need like a solution which worked across multiple computers. But then it's a matter of time. We might have a different node tomorrow, a second node tomorrow, and then we'll need to have a solution where we need to ensure it across multiple computers. Now, there's a AWS DynamoDB it's like a specification but with a Java client by default, which is the link here, which sort of uses AWS DynamoDB to basically implement something like this, which is you obtain a lock, using DynamoDB, which means by default it's distributed. You do the work and you release the lock essentially. So while you're doing the work, if somebody else is trying to obtain the lock, it'll basically either you can wait, in like a spin loop, or you can exit and try it after a while. So in this, so we'll also see how we can, shell out to external programs as part of this recipe. So yeah, let's see how we do it. So the package I'm using here is like a Golang implementation of AWS's Java sort of implementation. It's like a Golang equivalent of it. The API looks like this, so it makes it really easy to use it. So we create a structure of DynamoDB lock client type. We give it a name, which is going to be. So that's how you ensure that for a particular program you can only have a lock of a certain name. You can only have a program running only once. So you give it a lock name, you give it a least duration, you give it a heartbeat period, a table name, which is DynamoDB table name that you want to use, and then you give it like a client, which is a DynamoDB client, for which you have to use the AWS Go SDK. So you create your lock client, and then essentially we have this loop here, which is like actually, do I need the true? Probably not. Yeah, I think I don't need that. I think it's have it there. This is an example of an infinite loop in Golang, where you just specify like a for, and you, anyway, ignore that. So this is an infinite loop. So what you're trying to do here is we use this lock client object that we created earlier to get the lock. If you have got a successful result, we just break out and return the lock client. And if not, we basically keep trying till you get a lock. Of course, depending on the kind of logic you may want to implement, you could either wait for a certain time interval and just break anyway, returning an error. But so yeah, we obtain a lock here, and then we do the work. Now, I mentioned that the work that we're trying to do here is execute the user-specified script. It could be a single command, or it could just be a script. It also accepts arguments to it. So exec.command so exec package in Golang is what facilitates this kind of workflow. So first of all, we create a command object with the command that you want to execute. os.args is a Golang slice. You can think of it as an array. They are different, but if you're not familiar, don't worry. It's like the semantics are similar. So os.args has the command line arguments that your program was invoked with. So the reason here I have 2 here is simply because of the program I was working expected that the command that to be executed as a second argument, but is the command program itself, and then the other arguments that were supplied to it. So you construct the command object first, and then you have to how do you specify the arguments that you want to specify the command? We essentially what you do here is basically iterate over all the arguments from the third item of the os.arg slice, and then append. So append is a function that you use to append items to a slice in Golang. So c.args is the c.args is the slice of arguments that your command will be called with. So you basically iterate through it and just keep adding it. So this for range actually returns you 2 items. So one is the index, but I don't have any use of the index here, which is why I have an underscore here, because I want to just ignore it. And a is the argument itself. So we have constructed the command object. We have given the arguments that you want to execute with. And then what we do is we call this function called combined output, which is essentially going to give us the standard out and error combined. So basically, it returns us 2 values. One is the out error, one is the combined output and error, and the second is the error value itself. So if the command that you're trying to execute executed with a non-zero code, your error object will be non-nil, which is what you can check here, and use the os.exit function to exit with a 1 error code, which will mean our entire program will exit with a non-zero exit code, else we'll just print it. And once we're done with all that, we just basically call this remove lock function to give up all lock. So the key packages and would be the DynamoDB lock client, Golang implementation, the AWS SDK for Go, OS exec, and the time package. So I've got this working example in my GitHub repo on this particular link as well. So you can check it out. All right. So this brings to my fourth recipe. How much time do I have? No idea. Okay. All right. Good. This is my fourth recipe, and this is way more complicated than the others. But what I want to illustrate here is how you can use Golang to, perform an operation, periodically. Now, just to give an idea of the use case of it is, it's like one of our teams is focused on some analytics and pricing, tasks that they perform for our other products, as well as they are themselves like a product that we other companies use. They use Prometheus to gather and analyze certain metrics, which are usually very expensive to calculate. So they have a lot of business logic in them, and they are basically derived by running some SQL queries. Now, since these metrics calculation are expensive, each scrape target only exposes like a subset of the entire collection of metrics, because if all of those metrics were to be scraped, if all of were to be calculated every time there was a scrape, then it would just time out because they're just quite expensive. The list of these targets are exposed by a special HTTP endpoint, but however the list of these targets can change often. Hence we need to basically make the Prometheus server aware of any of changes in this targets list in a fairly automated fashion. So what you needed to have is something which basically scrapes this HTTP endpoint to read the list of targets and regenerates this Prometheus SD config file periodically. And Prometheus by default will always watch changes to this file, and that would solve the problem. We obviously could not use any of the native Prometheus service discovery mechanisms here. Hence we're using the file SD configuration. So essentially this boils to performing an operation periodically. Now we could solve it in various ways. We could use like a systemd timer, but that ties us to our operating system. That doesn't play well with this modern Kubernetes world, container world, where we are running stuff differently. We could use bash and slip. In fact, that's how actually the team itself ended up implementing it. Using Python, they used Python to generate the config file, but have this bash script sleeping and then just re-executing the program. Or you could use something called a ticker in Golang, which is what we're going to see. So I have this massive image to show why this was needed. While I was doing this, I felt maybe this is not needed because I'm having so hard to explain why you need this. But I don't know. I reasoned myself into the fact that okay, maybe we need it. But anyway, I'll gloss over this. But the GitHub repo I have at the end has this. So if you're interested, definitely check it out. But this is what I really want to talk about, which is how you perform a certain task periodically in native Golang. So Golang has this concept of a ticker, which is the time package. So essentially, a ticker is as the time as it you can probably guess is it's like ticks on. It's you give it like an interval, and it will do something that every particular interval. So let's say you have given it 5 seconds, it will do something every 5 seconds. And how does it do that? So essentially, we create this ticker object. Then we have a go routine, which is the hopefully very clear here, which is the go keyword, and then a func. And then we have this for range ticker.c, which is a Golang channel, which this ticker object exposes. Now the way it works is every time, so let's say if you are given, initialize this new ticker object with 5 seconds, what this is going to do is every 5 seconds this loop is going to be executed essentially. That's all you need to know. That's all I needed to know to basically achieve what I wanted to do. And then you basically do whatever you need to do. In this case, I was scraping HTTP URL, basically reading the HTML page and then parsing it and then generating the Prometheus file SD configuration. Which sort of brings me to the next step of this, which is how do you parse HTML files in Golang? Now you may need it for something else. So there's a package called GoQuery. Really found it very useful and very easy to use. This is probably one of their, like just based off one of the examples that they had. So essentially you initialize a new document and from the reader object. Now you can see here I have this resp.body, which is basically the response object of a HTTP GET request. And we initialize that, and then here I'm interested in basically going through all the HTML href links, right, which is the A tag. And I want to do something for every of those A tags. So I basically have this function find, and the tag that I want to find here, which is A for the hyperlinks. Then we have this anonymous function here, which has two parameters. One is the index, and then we have the element itself, which is the one that I have currently processing. And then I'm basically looking at the link from the href attribute, and then if it exists, if it's a valid href attribute, if the link, if it's not just a normal, a bogus A link, but actually has a href attribute, I try to parse the URL, and then I basically append the parsed URL into an array. So by the end of this parsing, my target links slice will have all the HTTP links in that HTML page. So, and then I basically use that to generate the Prometheus file SD config. So this GitHub repo has this code. It basically is a functional code, which we're using for this particular task. The package that basically needed to use for this is the standard library time package and this GoQuery third-party package, which was really useful. All right, so that brings to the last recipe. This probably is only going to be relevant to you, or you may even empathize with me if you have used Terraform and you have had to import a lot of cloud resources into Terraform. Having to write Terraform import. And then also, because Terraform import doesn't support generating the resource files, you also need to write the resources itself. Now, doing it for a one-off S3 bucket is fine, but doing it for a bunch of DNS records, that suddenly becomes very manual and error-prone. So here's a strategy. We are going to, so in this case, I had to import a bunch of Cloudflare DNS records, and this is, so I used the Cloudflare Go SDK to read the current DNS records, generate Terraform code, and also generate the Terraform import commands. And this is how it looks like. So, and this is one of the things which I mentioned right at the beginning, that all of these infrastructural products and companies, apparently they all have a Go SDK or a Go API client, so it's really very easy to integrate with them. So the first bit is we're creating the Cloudflare client. So os.getEnv is a way to get the value of an environment variable in Golang. It returns an empty string if the environment variable is not defined. So we create a Cloudflare client, and then we use this function called zone ID by name to get the zone ID, and then we use this DNS records function to essentially get all the DNS records. Quite simple. And so we have got the DNS records now. The next bit is how do we generate the Terraform configuration. So this is, if you're familiar with Terraform, this is how our Terraform configuration looks like for a Cloudflare record. So you give it, so a single backtick in Golang is a way to basically write multi-line strings. It preserves the spaces as well. So I'm calling it TF template, but it's actually not a template, it's just a string. Golang has its own templating mechanism. I think the idea was to convert it into a template, but obviously that hasn't happened. So basically pretty simple sort of format strings here. So the first bit is the %s, which is the resource name, and then you have a bunch of stuff to fill in, like the domain, name, type, value, whether it's proxied or not, and priority. If you are following along, you'll notice this %v here, if it's visible. %v is a format string in Golang, which you should use when you're not sure what to use. In most cases, it works as you expect it to. So that's our string, and then the strategy is to basically use all these DNS records that we have just read and render all these resources. And this is how it looks like. We basically use, so because records is an array, we essentially go through each of those records. So this is an object, so the content is like the DNS records value. We use the format sprintf function to generate the resource name. The idea is simple. We are going to name the resources as record underscore IDX. So record 1, record 2, and record 3. And then we again have a couple of sprintf calls. Similarly for the import command as well. So we have the Terraform import, Cloudflare record, and then we have a bunch of stuff. And this is an example output. So this is this is the Terraform resource output that it would generate. And this is an example of the Terraform import commands it would generate. 5 minutes, all right, okay. So key packages, Cloudflare Go, strings, and FMT. Now, miscellaneous. So one of the things I think I initially wanted to discuss or make this talk about, but it ended up going into a different direction, was how we also use like Golang for basic shell operations like reading files, reading a file line by line, doing regular expressions, checking if a file exists. Turns out when I posted this on something on Twitter, there's a guy who basically the author of this package replied to me, I have this package which is basically trying to do the same thing, and it looks really nice. It should definitely be worth checking this out as a replacement for your normal bash commands. So definitely check it out. We haven't really talked about some of the basic stuff like read a line of input. Now, sure, you can tell me this is what you need to read a single line of input, but whatever. you need it. So, but yeah, that's how you read like a single line of input. Reading a password, we need to use this package called SSH terminal, and we need to give it like the file descriptor of it which you are trying to read from. So way lower level than you would want it to, but that's Golang. We have sort of discussed these things a bit, which is os.args has the slice of command line arguments, os.getenv has the environment variable, and lookupenv similar. There's a package which I really found useful for tabular output called TabWriter. It's a standard library package as well, so that's really useful. Well, not actually standard library. Oh no, it is standard library. Yes, so it's a standard library package, but really found it useful for tabular output. This is another package which I have been using of late. Pretty like I've really found it very useful. Called Go Fuzzy Finder. It's like a FZF like search interface terminal UI. And then the real templates, which I was talking about, Golang has both support for text templates and HTML templates. I have this blog post where I went through a few examples of using it. And then we have, we haven't talked about command line frameworks, but if you have looked around in the Golang community, there's this called Cobra by SPF13, and which I've been using mostly for all my work. But there's another contender called CLI by YourFav. I haven't used that. Looks pretty nice. Shell auto-completion, like all these frameworks, they have really good support for shell auto-completion and documentation generation as well. So just a bit about what we have been doing for automation at Covergenius in terms of Golang. So one of the things I did, about like maybe a month in or so was, we had all these scripts lying around, and there was all these tasks that were coming to for us to do, and like there were only two options: either do them manually or write a bash script. But I thought, okay, why not do something else? Why not actually kickstart a Golang project and then start using it? My other colleague, who is also my, the only colleague, so we are the two people who is doing all the infra. He already liked Golang, so he was right into it. He has been writing tests as well, which is really great. So what we have automated so far: various AWS tasks, some AWS Kubernetes related user access, Kibana filter management, Grafana backups, LDAP. Postgres streaming replication, and some secret management. It's obviously an ongoing project. So yeah, just to conclude, so basically I feel that we have this excellent ecosystem around Golang plus operational tasks, thanks to all the people who obviously shared their code and learnings. Hopefully I'm contributing to that. But obviously time is always an issue. You have you have this, hey, I'm having this issue, and yeah, sure, okay. Now I have to stop all that and do that. But if you only have the time with shelling out, just do that, and then maybe write it as a proper Golang task later on. But it's a start, and often you just have to commit to it to actually see progress in it over the time being. And Golang obviously makes it very easy to distribute the tool to our developers who use like Linux, OS X, and there's one person who uses Windows, so so not a problem with that either. So yeah, thank you for having me here, Katie and Josh. Thanks to you all for listening, and thanks to all my colleagues at CoverGenius for not questioning why a DevOps engineer needs to write Golang. Yeah, these are my contacts. Slides will be, I have shared the links to the slides on my blog, so definitely check it out. And may the force be with you. So that's a website I discovered called gopherize.me. If you haven't checked out, you should check it out. It generates custom gophers. Yeah, thank you.
A friend of mine, who's going to be speaking to us about distributed metrics at scale. Thank you, round of applause.
Hello, I'm here to speak about metrics, especially metrics at scale, and especially distributed metrics at scale. Who am I? I'm a software engineer, and if you ask any of my current or previous colleagues here in the room or from one of my previous teams, they will tell you that I'm interested in observability and Golang. And what are metrics? This is a definition that I found in Wikipedia, which is software metrics is a standard of measure of a degree to which a software system or processes some property. I can't even assimilate that. So most of us, when we think about metrics, is we have applications. Those applications do something. If they didn't do anything, you wouldn't even have them, okay? So at the very least, we monitor how often we do this thing. Do we have more than one instance of our application doing this thing at the same time? What's the duration of each of these processes or procedures? And usually input byte size, output byte size, and you might have many other application-specific metrics, but at the very least, you would be monitoring these things with some labels for status of success and so on and so on. So when I speak about metrics, usually I speak about metrics like these and some kind of a quantitative representation of the state of your application. Be it something that you increase as a counter or some value that changes over time arbitrarily. So why do I care about scalability? Obviously, everybody cares about metrics. And if you don't, you have other problems. Obviously, we need the metrics, for alerting, for monitoring, and I don't even need to explain that. But why do I care about scalability? A couple of months ago, maybe, I don't know, several months ago, I joined a company that's called Section. So I have to deal with scalability at my current team. And especially, I have to deal with scalability of metrics, and not only. So what we do, we provide a multi-tenanted edge compute platform that allows you to run basically any containerized workload. It doesn't matter if it's your own or a set of third-party integrations. And everything we do is in Docker and running in Docker, and it's managed by Kubernetes. A couple of friends that I have here in the crowd told me, oh, you moved to this CDN provider. So I added this slide just for them. We are not a CDN, okay? So I know that the vast majority of the internet nowadays is still cached in CDNs. And when I say vast majority, I mean really, really vast majority of the content, the static content. But the CDNs, they were created, many moons ago, when most of the users were desktop users. And CDNs are usually black boxes, and oftentimes they do not, comply with modern DevOps practices. Like you have to log into some interface and change some things in order for some magic to happen. So the state of the edge, basically, I care about scalability because we would like to change the edge. In the past there has been pure architecture choices. Most of the CDNs, they have been designed so that they could just cache some static data into some non-flexible locations, static locations. And we would like to have flexible locations. We would like to move our edge workloads. Also in the past, systems usually had problems with changing rapidly and quickly, and we would like to be able to react to changes and give options to our users to react to changes much faster. And lastly, we would like to do this in a DevOps way where you just push something into Git and the things just work for you in an automated fashion. So we do have, this is some representation of a world map. Later I'll show another one. And each of those little logos are basically Kubernetes clusters. By the way, our points of presence are completely different. But what I want to show is that we run many of these, okay? And then we have multiple layers, and when some requests arrives, it goes through multiple containers, and then eventually it might go to some origin server if we happen to be hosting a CDN application, but we might be hosting other things as well. Just to give an example, we might be hosting DDoS protection or some kind of firewall, or we might be hosting some authentication solution, or we might be hosting any type of user workload. And then more specifically, I'll come back to the question, why do I care about scalability? Okay? How a traditional edge computing, or maybe classic edge computing or CDN platform works. And a request arrives, and then you route this request to the nearest server, and then the strategy has been to place as many servers in as many locations so that most of the users in the world, or maybe in the target locations, would get a fast enough response. Okay? This strategy is outdated. It's not modern. We would like to change that. And the way we would like to change that is basically, I'm spending some time on this because this is really important for the metrics. Usually when people care about scalability, they refer into automatic scalability, things like pod autoscaler, in the Kubernetes context, where your application expands and collapses, instances based on incoming requests or some other metrics. Or maybe your cluster expands and collapses based on some metrics. You add more nodes or you remove nodes. In our case, we add Kubernetes clusters or remove Kubernetes clusters, okay? So we extend the network. So we basically extend the entire network, and then we shrink it back to, a smaller size if that workload is not needed anymore. And to give a more specific example, we can give you an IP address, and then we can announce that IP address from many different locations, and then we would serve, a request from the nearest location. But what's so far it sounds like a traditional old school CDN. However, we are not running just caching. And the thing is, we do not want to route your request to the nearest server. We want to move your workload to where the users are located. So if we detect that your workload comes from some place that, that there are many users at this time, we will basically deploy your location there. And then when there are no more requests coming from that location, we'll just queue that cluster, take it out of the system, or workload, or application. So that explains the level of scalability that we are interested in. And all these things are automated and driven by metrics, okay? So usually most of you, or maybe most companies, would use Grafana, and maybe Prometheus or some other kind of metrics data source, something like Graphite, and you would have dashboards like these. Okay, in these dashboards you would be visualizing any type of important information about the current state of your system. So far it sounds so positive. Let's monitor all the things, and if we just think like that, sooner or later we face scalability issues. So not monitoring anything is obviously a big issue. Okay, if you are in a team where you don't monitor anything, it is highly advisable that you change that. However, having way too many metrics can present significant challenges to even the most advanced teams. And let's, for example, start with a single Prometheus instance, right? That's one of the most popular monitoring solutions out there. It's open source, not a huge difficulty to start using it. And then sooner or later, you face with, some limitations of that, single Prometheus instance, and you add some kind of remote storage. I've given an example with Elasticsearch. On their website, they have a list of at least 20 open source solutions, and there are some paid ones as well. And then even with something that is scalable, the storage backend can be scalable, sooner or later you face other scalability issues, right? And in our case, we have multiple regions. So even if we use federation with Prometheus, just to mention for the people who do not know what that is, it is a setup where you have one centralized monitoring system which basically scrape metrics from remote Prometheus systems, and then you can query the metrics in one centralized system. The problem with this method, though, is that you have to pay for a transfer cost, okay? So if you happen to be using many Kubernetes clusters in different cloud providers, as soon as you start moving data over the network, and we're talking about millions of metrics, then you start paying, huge price for that. So with scalability comes some problems. And this, by the way, this does not apply only to metrics, right? You are going to face these problems with any type of scalability, but here I'm here to talk about the context of monitoring, okay? So to name the 3 most popular problems that you're going to face, these are performance, cost, and reliability, okay? Now, pick 2. So with almost any solution that you're going to find, because there are many, I'm going to give you one point of view, one possible solution to the problems that we face. There are others. I'm not claiming that this is a silver bullet and it's the best solution. Also, many companies don't even need that level of scalability. But with most solutions, you have to pick one of the sides of this triangle. And I'm here to talk about a project that's called M3DB, right? It was, I think it's popular for this audience because it's written in Go. It's relatively young, so it's been open source, I believe, about 1 year ago. It was initially developed at Uber to solve some scalability issues. And it's still under development, right? It's a growing community, it's a trending project, it's very nice for someone who wants to contribute to open source project, or maybe someone who wants to solve some of the problems that they have with their metrics internally. So what the M3DB team did is basically they were faced with a lot of Prometheus and Carbon metrics that they were not able to scale anymore, right? They were scaling to a point that was not feasible to continue anymore. So the architecture of the project is kind of similar. They have broken Prometheus into microservices. If we think of a Prometheus like a monolithic system that does a lot of things, they have decided to break the pieces of Prometheus into smaller components and then scale or improve each of them independently, okay? So at the very least, you can use M3DB as a remote storage for Prometheus. So it can be a drop-in replacement of whatever remote storage you use, and then you can start with M3DB right now with little setup cost. In addition to that, it also accepts StatsD and Carbon metrics, and they have a few other nice features. They have an external aggregation engine, which I'll talk about in a second. And they also have a separate query engine. So these things are separated in different components. Key differentiators of M3DB are first and foremost reliability, okay? So obviously you can achieve this with some kind of a remote storage, but every single read and write in M3 is done with a quorum, which means like with the majority of the nodes confirming the data, and also it supports regional outages. I will talk about this in a second, but basically it means that if you lose some of your M3DB instances, you are going to continue to serve traffic, metrics, alerts, and things like that. Obviously, you want your metrics to be reliable and fast, right? If you have delay in metrics, obviously you have delay in your charts, you have delay in your alerts. Not to mention, if you have timeouts, you will not even receive alerts that your metrics are not available. It is highly efficient in terms of storage. So one of the key strategies and goals when building this project that it was designed to solve was storage space. So it uses, they have focused their time on compression algorithms. So M3 uses about 1/6 compared to competitor projects, 1/6 of the space. And the third feature that they have focused on is an inverted index, which improves the performance of the queries. So at scale, when you have huge amount of data points for each of the time series, inevitably you end up with slow queries and timeouts in your dashboards. Like every now and again you have this loading, spinning thing that, you know, some charts appear, some charts don't appear, and it can be, you know, at the very least annoying. So as I said, this project was developed at Uber, and the team lead of the project sent me those numbers, which look impressive. And obviously, we don't have that kind of scale yet, but it's a project that has successfully proven to be able to index 11 billion metrics and satisfy, you know, 20 billion queries per second in a you know, blazing fast manner. So they have managed to also achieve significant cost savings. So a little bit more about the M3DB architecture. So the key components of M3DB, the 4 key components of M3DB are coordinator, which allows you to write the multiple M3DB instances. So the coordinator exposes HTTP endpoint that can be used as a Prometheus remote write, and it can also be used as a remote read. Aggregator, which is responsible about aggregating your metrics. Usually, aggregating metrics is something that people don't think about until they have to scale, okay? And that is because we don't have a lot of data. But imagine you are receiving huge amount of data and you don't want to store that data for, I don't know, every couple of seconds. Maybe you want to have some aggregations and store 1 data point per minute. And then maybe for the first 24 hours you would like to store the metrics with no more than, you know, 1 data point per second, but then as time goes by, maybe for the first week after the first day, you need 1 metric per every 5 minutes, and then for first month, 1 data point per every hour, and then after the first year, maybe you need 1 data point per day because you don't really care about spikes, okay? So you can get entire time window, you can get maybe some aggregation strategies, doesn't matter which one, let's say a mean, then you get a data point, and that results in huge compression in the storage space required. In addition to that, it improves query speed performance, okay? So M3 coordinator speaks with the M3 aggregator to achieve that. In addition to that, the metrics are stored in shards and namespaces, and this allows some metrics to have different retention period than other metrics, okay? With most traditional metric solutions, you have 1 retention for all your metrics. With this one, for example, we are providing a multi-tenanted system to users. We would like to have 1 retention for our users metric, and then different retention for our ops metrics that we use to monitor our platform. So with M3DB, we can achieve that. And finally, there is a component called M3 query, and M3 query can be used as a remote read for Prometheus, but it can be also used as a Prometheus data source in Grafana. So since it has exactly the same API as Prometheus, you can use it in Grafana as a Prometheus data source. Now it has one other really cool feature. It has fan out queries, okay? So I will actually go back in the slides to my map, and I have 2 different type of clusters here. The green, by the way, a disclaimer, our points of presence are completely different. These are random, those that I put on the map, okay? So this has nothing to do with the reality. Obviously, the clusters can appear and disappear at any time. So this is similar to monitoring serverless, okay? So in serverless, you have the gone in 60 seconds problem, where you want to monitor something that by the time you want to scrape it may not be there anymore, or even if you scrape it, it might continue running and then disappear. So anyway, that's different. You have to push metrics there. But usually what happens is these green guys, sometimes they're short-lived, sometimes they're long-lived, sometimes they might move to a different location. in future, and we might have, we might achieve something like, moving the workloads only when there are requests. And the red dots, they are auxiliary clusters that would be a little bit longer lived, and they would store the metrics for all the green guys, okay? Now, we don't want to ship the metrics to a centralized location because that costs money. And we're a startup, we don't have that much money, okay? We are not Microsoft and we're not Google, so we do not want to ship the metrics, that's expensive. Like once you go to millions of metrics, you don't want to ship them anymore. You only want to query them on demand. The problem that we face is that some of our customers, actually the vast majority of our customers, have workloads on more than one point of presence, okay? So, for example, we might have a customer that has, their website behind a firewall and DDoS protection in Sydney and maybe New York, okay? So when we want to query the metrics, we want to get the metrics from both locations. And the problem is that at query time, we do not know where the metrics are located, okay? So what the M3 query does, we have one M3 query in front of every M3DB cluster, and we have an M3DB cluster in every one of the red guys, okay? So when we send the query to any of the red guys, it fans out the query to every one of the other red guys, and then receives the result from them, then merges the query and returns the query to the users, right? It's some kind of, M3 query can use two backends. One backend is M3DB, the other backend is gRPC, which happens to be other M3 queries, okay? So this results in shipping the metrics on demand only if somebody queries them, okay? So this is very important because when you query metrics, usually in the query you can aggregate them and you can return a few data points for your query, or maybe more than few, but it will not be all the metrics. You will not do the aggregation at the point, or you will not have to ship all the metrics. This is what I mean. You don't have to ship all the metrics to a centralized location. You have the metrics living where, or close to where they came from, and you don't have to ship them across the ocean unless nobody queries them on the other side of the ocean, okay? So this is a really important feature of M3 query. Fan-out query is something that is super important for us. But even more than that, imagine what happens in terms of reliability. What happens if we lose some of the important guys, the red ones, okay? If you lose one of these clusters, like completely the region goes down. Maybe something really, a disaster happens and we lose a region, okay? Not availability zone, we lose a region. Then all the others are still alive. And then, since we have one IP to query all the red guys, then as soon as one of them receives a query, it will fan out to all the others which are available. And then we will still query the metrics of the users who are not hosted here, okay, in these points of presence. So even in a huge disaster, we will not lose everything. Because when you have a centralized system, if the centralized region goes down, you are pretty much, I will not say the word, but you're in a bad situation. And in this situation, if one of the red guys goes down, we can still reliably and performantly query the other guys, get the metrics from every other location, and then and by the way, we'll receive metrics that this guy is down. Because if your centralized system goes down, you might not receive alerts, okay? So we will be running in a degraded mode, but not without any metrics. So we'll have a geographical distribution as well. So this is, some of the nice features that M3 query provides. So M3 query obviously provides the same HTTP endpoints as Prometheus in terms of remote read and remote write. You can use it with your favorite alerting solution or your favorite, graphing solution, something like Grafana. Each of our clusters, the red guys on that map, has its own Prometheus in our case. You could completely replace Prometheus because the M3 project also provides something called M3 connector, which scrapes metrics, and it's a very small Golang binary, extremely small. We are not using it yet. Hopefully someday we will. And then these Prometheus instances use M3 as a remote storage. So we store the metrics there. In front of that, we run M3 query. And then Grafana queries one of the entry query instances, which happens to be the closest one. And then we fan out the query to all of them, and we receive the metrics back. Okay? As I said, this is not a silver bullet solution. You might not have this level of scalability, but it might still be useful for you. Okay? Imagine that you have an active deployment. For people who do not know what this means, it means you're running your, maybe you have a system in Sydney and you have a backup system in Tokyo, so when the Sydney region goes down, you can use the other one. So this means that you have metrics into regions. How do you query the metrics into regions without shipping them to a centralized location? Okay, you don't know which location is more reliable than the other one. In other solutions, you might be running with multiple Kubernetes clusters. Maybe you have Kubernetes cluster with your staging workloads or your test workloads or maybe production workloads. You want to query both of them and then compare the graphs, staging versus production. Or maybe you might have shadow traffic that goes, the production traffic gets sent automatically to the staging environment, and then you want to compare the metrics from more than one, environment that do not live together. They might even be in a different clouds. So being able to distribute your queries is really a useful feature, especially in our case, where we face scalability issues and cost issues. So the global reads is something extremely useful for us. I'm not going to show any code right now. The entire project is written absolutely 100% in Golang. But if you are interested in checking some of their demos, for example, the fan out query demo, all of these demos run in Docker. So if somebody is interested, you can go to their GitHub repository, and under the scripts Docker integration test, you can see interesting demos. So I'm not going to lose your time by running Docker run or Docker compose run up whatever. You can just check the getting started section in their documentation, or you can check the examples that they have on their website, in their GitHub repository. I'm sorry. In addition to that, fairly recently, they happened to open source another project, which is the M3DB operator. Okay. Again, the M3DB operator does some amazing things, like expanding and shrinking M3DB clusters, adding nodes, recovering nodes when one of them disappears. So M3DB can be 100% drop-in replacement for your Prometheus cluster. Obviously, that comes with some maintenance and some complexity in terms of your monitoring system, but this is something that we had to deal with, and we couldn't avoid. And with that, I believe that I'm close to my limit of 30 minutes. Any questions?
Sorry, quick question. You said with your distributed query, it allows you to go and distribute out that query. Now, when you're talking about certain statistical properties like P99, P95, or the median or standard deviation, it's very hard to distribute that calculation out because depending on volume, it biases the overall calculation. How does MQTT deal with that?
The question was, some queries cannot be calculated at the origin. The centralized location needs all the data points in order to calculate the result. And yes, in that case, obviously the metric needs to be shipped to the entry query that is executing calculating the result. But usually we do not query the entire data. We only query some time window, whatever is set in your dashboard. So yes, in some cases, all the data points of these metric series will be shipped only for that data window, and then the calculation will happen at the entry query instance that is executing the query and returning the results to whatever client you have.
Thanks for your talk. I was curious about how you sort of went from, say, vanilla Prometheus to M3DB. Like, what kind of problems did you start facing, and then what was your journey like? Like, what are the kind of solutions you tried to do and then failed, and then eventually ended up with
there initially, one of the things that we were having problems with is obviously the very first thing that we have is shipping the metrics to centralized location is involved with cost. Okay, so every reasonable team would like to reduce cost. If you can achieve exactly the same result with paying less, you would do that. But in addition to that, imagine that you have metrics in different continents. You want to get them to a centralized location, and your Prometheus federation is running into timeouts. What happens? Next, you start losing metrics. If it happens long enough, you lose metrics. And for us, it was happening long enough, so that this bothers the team, and then we have to look for a solution. Because every now and again there are network hiccups when you want to move all the metrics. So instead of moving all the metrics, we're moving only the parts of the metrics that are being queried, for the time windows that are being queried, for alerts or dashboards or things like that. That's it. There was a
what about alarms? I saw that there was some mention in your one of your slides regarding alarms. How are those handled?
So, as I said, M3DB supports the interface, the HTTP interface for Prometheus remote read and remote write, which means that any graphing or alerting solution that would work with Prometheus would automatically work with M3DB. So, to be more specific, M3DB does not care about your alerts. How do the alerts work? You have some query that is being run on a timely basis, and if some value goes above some or below some threshold, then you receive, you get waken up during the night. But your alerting solution doesn't really care where the metrics come from, as long as it's an HTTP endpoint that implements that interface and returns the same format of data.
I think we might be out of time. I'm really
Okay, last question.
House orders.
You've got a query fan out. So the M3DBs know how to talk to the other M3DBs. Does M3 itself know where the other M3DBs are? Or have you had to orchestrate how it talks to all those other locations?
So the question was, in the fan-out query, does M3DB know where the other M3DBs are? So if you're talking about M3DB instances in the same cluster, the consistency and knowing about each other happens through etcd, the same way it happens in Kubernetes. So the M3DB cluster gets its consistency through etcd. Then the clusters themselves get fan out through M3 query. One cluster does not know anything about the other clusters. And I believe I'm running out of time, so I'm not allowed to answer any more questions.
All right, I'm between you guys and the pillow waiting for you at home. So I will try as much as possible to move quicker. I'm going to have a demo by the end of the presentation, so hopefully I can go through the presentation as quick as possible. So pretty much this presentation is to share my experience on learning Go. The Go is not my main language, it's not my bread and butter. It's something that I've been passionate about and want to learn about it. So this is my journey to learn Golang and also to learn about containers and Kubernetes at the same time also. So who am I? I'm working for a company called Kasada.io. We are a security-based company, a startup company. I work there as an Android security engineer. My main is customizing Android. So if you guys are using Android, my role now and before is also like customizing those operating system. So my forte is in that space, the low-level space, and also developing Android application. I've been doing that reviewing for Android books before. One of the book, Android System Programming, that's a very low-level kind of a book. So if you're interested to learn about Android, very low-level, that's a good book. And Expert Android Programming is just an advanced kind of a book for Android. I write a lot of articles about Android internals for open source magazine. It's free to download. You can download it from magazine.odroid.com. So that's pretty much out of the way. So let's get into the meat of things. Why I want to learn Go? Well, I'm interested to learn new languages. I'm very passionate about low-level languages, C, C++, that's the person I am. I love to learn any kind of languages that is very low level to the kernel side. And I noticed that when I was looking at this Go, I noticed that this is the de facto standard language for container. So I thought, okay, maybe it is a good way for me to learn Go. At the same time also I learned about containers, Kubernetes, Docker, all these kind of things. And the nice thing about Go that I found was you can run as a single executable and you can compile it for multi-platform. So this is something that's close to me because I also write code in Android, which is Java based, and Java, as you know, is also multi-platform. So this falls into that category where it's not too low level, it's not also high level, but right in the middle kind of thing. So it's right, I'm very comfortable at looking at Go then. So then what did I do then? Why did I choose Minikube to learn Go? People say, are you crazy? Are you mad? You learn languages, you learn from the basic, right? You go, syntax and things like that. Well, probably because I'm a bit crazy in the sense, because I've been working with Android operating system for quite a long time. My mindset has been in a massive code base. So I work with code base which is hundreds of megabytes, like Android. So for me, it's like, why don't I just jump into it and see where does it take me? Where does this going to take me? So then I thought, okay, at the moment Kubernetes is something quite big and quite everywhere at the moment. So I thought, okay, let me tackle something very smaller size, not Kubernetes itself, because I thought, okay, I don't want to spend too much money on buying hardware and going to Amazon and things like that. So I thought, okay, let me take a look at Minikube, because Minikube can run on a single machine. So I thought, okay, let me dissect this beast, which is called Minikube. And at the same time also I was thinking, looking at Minikube, I thought, okay, I can learn Kubernetes and it's on a single package. You don't have to worry about, oh, I need this, I need that. I can have my laptop, sit in a cafe somewhere, learn Minikube, learn Go at the same time. So it's very, very convenient for me. So, and then at the same time also I thought, oh, okay, now that I can learn about this, I can learn Go, what else I can learn? It looks like when I look at the source code, there's a lot of advanced Go kind of way, programming architecture that is using, and also a lot of design pattern that's using. Coming from a Java background, it feels really at home for me. So I thought, okay, I'm in the right track right now, and then and Kubernetes, as you know, is really solving a very complex distributed system problem, right? So at the same time, getting all this benefit, by learning a single project, and I'm getting, the cream of the crop basically. So it's good then. Okay, so then what I did was I learned Minikube. I check out the code. I used the IDE from JetBrains, and then I start hacking into it and trying to learn what is Minikube all about, how does Go is being used to use Minikube, what does Minikube use, and all this kind of thing. So different kind of thing. So during this demo, I'm going to show you, I'm going to run and debug Minikube from the source itself. I'm going to launch Minikube VM using VirtualBox. So if people are not haven't used Minikube before, Minikube is using for Linux itself is using VirtualBox. So that means if the VirtualBox, if you install VirtualBox on your machine, you can pretty much use the same VM that is created by Minikube itself using VirtualBox UI. And then also, you will get a lot of benefit once you get into the process of learning Minikube and learning Go at the same time. So without further talking too much about it, let's get into the code itself. So what I have right now, can everybody see what I'm showing here? Yeah, okay. So what I have here is, this is the Minikube source code on my IDE. I'm using Golang IDE. I'm using the free version. The version is very expensive, so I'm cheap. I'm using the free version. So I'm using Minikube. This directory structure that I have for Minikube is inside my my Go path. So if I show you my Go path is that is where I store my my Minikube. And pretty much this Minikube that you're looking, the source code here, this is taken from master, right? So this is for master. So what I'm going to do is I'm going to try to run Minikube now from the IDE itself to show you what it does actually. So the first time when you check out Minikube, normally when you want to find, the first thing is you want to find the function main. Where is the function main that you want to run, right? So normally what I do is I just do a search. I don't know whether the key, sorry, the key is not working. Okay. All right. So what I do is I want to find the function main that I want to run. Now in this case, there's a lot of function main. So after I do the investigation, then I notice that, oh, okay, looks like, sorry. Anyway, sorry, let me just grab the code itself. So after looking at this, then I noticed, oh, okay, this is the main function that I have to call to run Minikube. All right, cool. So what I've done is I've created here a configuration to run the Minikube, and then I want to run that. Now the first time when you run, you will get an error. Okay, so it looks like what happened is Minikube require some code to be generated using the make file that is available. Cool, that's no problem. So what we can do is we go to our terminal, and then we're going to run one of the tasks from the make file, which is to which is basically text files and translation files that is required to run Minikube. So once I generate that, what it is doing is basically generating all the Go files that's needed to run Minikube, which is going to be packaged together. So once I'm done with that, then I just hit the run, and then what it's going to do is going to do a lot of process where it's going to run the ISO files. Sorry. So what it's going to do is going to create the virtual box, and then from there is a backend process that's running, that's checking whether the ISO file, which is the system that is going to use, or the file that is going to use to generate the VM. Now normally it's not very fast because I've already run it before to make it faster, so that saves a bit of time. So at the moment right now, what you're seeing is relaunching Minikube in the background. So what it's doing is just relaunching the Minikube again, and it's checking all the different services like the API service, the proxy, the etcd, all this kind of thing is running. So with that, I have already VirtualBox running Minikube. Now, how do I check that? Normally, this is how I check. So to see whether VirtualBox is running. So I know there is a couple of services that's running. It's called VBox service and Headless and DHCP. So VirtualBox is running now at the back end, in the background basically. So Now what I'm going to do is, I'm going to show you how I go through understanding how internally Minikube works. The way that I figure out was I noticed that there is a lock, that there is a statement, there is a source in the source code there is something that you can turn on the lock, so that you can see what's going on, what is the command that is being used to trigger the creation of the virtual machine, what are the commands that is being posted to the virtual machine to get the data that it needs to do all these kind of checkings. Now let me just quickly do something here. So what I'm going to do is I'm going to instruct Minikube to output everything that supposed to be output into the standard input and output. Sorry. Okay. So now if the next time I run start again, I'm going to see a whole bunch of logs coming out, and it's going to show me what exactly is going on when it hits that. See that? There's a lot of logs coming out now. So from here I can now trace back step by step what is actually happening when I trigger Minikube. So what is this doing actually? So if we take a look slowly, we can take a look at one. So this is all the log that is coming out for whatever operation it is doing. So as you can see over here, there is a command there which is called user bean vbox manage. So what is that? Is basically that is a command line application that's using, this is part of VirtualBox, to talk to VirtualBox itself, because it's already created a virtual machine earlier. And then it gets all this output that you see in the standard out, and then it just do a lot of processing to check what other information that it requires for it to start the process properly. Now the question comes like, if it is using VirtualBox to run Minikube, to run all the Kubernetes program inside VirtualBox, it should be possible for us to use VirtualBox to open up the virtual machine, right? So let's try that. I'm going to open VirtualBox. I will install my machine. Can you see? Okay. Okay. So you can see Minikube at the moment is running in the background, right? So the virtual machine is running in the background, right? So what I can do is I can directly just go there and then show it, and automatically it will show it's welcome to Minikube, right? So I can just log in. And I'm inside Minikube. So pretty much over here, as you know, if you have used Kubernetes, is leveraging a lot of containers. So one of the containers using Docker, right? So automatically Docker is available, so I can take a look at Docker. Oh, okay, there's a lot of images inside there, right? So I can take a look, okay, what are the processes that's running for Docker? So it's a bit squashy, cannot see that, but you can see over here there is a lot of Kubernetes specific application or containers, like the POS was a POS container, and then DNS, etcd, and all this kind of thing. So pretty much what you're seeing right now is Kubernetes in a box, right? It is running in a virtual machine. So basically whatever you can do in Kubernetes as a system, you can do it also in Minikube itself. So right now also you can see that you're already learning now, not only Go, but you're learning about VirtualBox. At the same time also you're learning about Kubernetes, and also you're learning about Docker also at the same time. You know, so you're killing so many birds at the same time. Okay, let me get out from there. Okay, so now that we know that it is using VirtualBox, I can open up VirtualBox, I can open up my virtual machine, it's running in the background and things like that. Now Minikube has got a lot of functions, so you can deploy your application using kubectl, kubectl. You can do whatever you want normally in a Kubernetes cluster with Minikube. Now let's try to step through. So the next thing that normally I do is, after I figure out a lot of this kind of thing, is the way I figure out a lot of this kind of thing is I step through the code, right? So what do I do? Where does the code lies? Where is which part of the code does what, and things like that. And this is very important for me, is because I want to know how the internal kind of thing works, so that it will help me later on to troubleshoot things, and also, if you want to contribute or you want to write documentation, that will be very, very useful. So one of the things that I found was, most of the command for Minikube, may there be Minikube start, may there be Minikube status, whatever it is. Like for example, I have here Minikube stop. What it means is it's stopping the Minikube. It can stop the Minikube, and I can delete Minikube delete. I can delete the Minikube. So most of the thing that I found was the command line. Sorry, let me just take a look. The command line parameters Minikube start, Minikube stop, that is being configured inside the directory called Minikube/command. Like for example, if I want to say Minikube status, I want to get the status of Minikube. So if I run that, I can get the status of Minikube, what's going on inside that, how is the API server, is it running or not, and things like that. So I can say, oh, the kubelet is running, the API server is running, kubectl is correctly configured, and things like that, right? And this is also using the same kind of configuration, or the same kind of way that's communicating to virtual machine, which is using the vbox manage command line tool from virtual, same kind of thing, right? And the interesting thing is, it's also doing SSH into the system, into Minikube also, to get some more information regarding the system itself, right? Now, this is all good, right? So how do I normally how do I now find out how does the status actually work? Is it really, how does it work, inside it? So what I normally do is, I know that status is the one that normally it does. It's called when you run Minikube status. So if I debug on that, I know that this is the particular line that is going to stop when it's going to call the when I run Minikube status. So it stops there, and then I can debug through it and see, okay, what's going on here. So okay, it's getting from lib machine called a new API client, and then it's getting some host status there, and then looks like, sorry, okay, and then it's getting the kubelet string. So like, okay, the kubelet is empty still. Okay, maybe this is not the way. There's getting the kubelet status. There's some other way. Okay, let's move on. Then we look at API server. Okay, what is it getting? Oh, okay, no, API server is still empty. No, it's not the way. Then you continue the process until you find out, okay, where exactly it is getting the data from. If you move towards here, you say, okay, so I'm getting the kubelet status by calling that cluster bootstrap get kubelet status, right? Okay, so let's go inside and take a look what exactly it is doing there. Is it doing using that, or it's not, okay. So if we run again and debug that part now to make it easy. Okay, so if we go inside and take a look, this is what it's doing. It's issuing this statement, So how does it do that? Well, normally looking at this, it must be doing SSH, right? Something like that along those lines, right? So now I know that, okay, so looks like it's not only communicating via user bin vbox manage to get all this information that it requires, but it's using some other way to communicate to Minikube, which is basically probably SSH, right? And this is the command that's using. So you see, by doing this kind of steps, this kind of process, you get the understanding more and more as you build up the understanding of the system itself, which is not going to be much different if you look at the real Kubernetes, which is the big brother itself, right? Okay, so that's that for the demo itself. So I just want to go through some points. What are the learning benefit that I got from this? Well, now I understand that a single VM host now hosts so many applications to run Kubernetes. So that means Kubernetes consists of so many applications, which is etcd, which is the DNS, the proxy, all these kind of things, right? And you can look at that, and then you can go to the VM, you can do whatever you want inside it. Basically, pretty much you can do whatever Kubernetes operation you can do in the real environment. You know what role the Docker plays inside Kubernetes now, because you can see that it is there inside. And VirtualBox is a VM allowing to test distributed environment, which is very true. This is a very quick way to understand Kubernetes in a very simple way, and a very quick way to understand by using Minikube. Because you are getting benefit not only understanding Minikube, but you're understanding about Go, you're understanding about the advanced thing that is doing with Go language. You're also looking at solving a very complicated problem, which is a distributed system itself. So thank you for that. So what I have is I have a website that you guys can take a look at. I just do a lot of articles regarding Kubernetes about my process of learning and things like that. So feel free to visit that. I always update that. It's always a work in progress kind of thing. So feel free to see it. Yeah, so that's it for me.
So any questions for Nick? Come on, surely someone's got one question. One question. Don't leave him hanging.
Going once.
Oh, there we are. Broke soul. One question.
I understand you understand the complex systems, right? And you love doing that. My question is that how we can start? Like person like me, how can step through all this? What you have? So that.
Okay, that's a good question actually. Different people has got different way of learning, right? So for me, this is how I learn, right? But if you should understand from yourself, from your point of view, is in what way you're comfortable in learning something new. Some people are comfortable going step by step. Some people are comfortable going looking into the code. Some people are comfortable if they do pair programming kind of things, right? Going to meetups, meeting with people and things like that. So I guess to answer your question is the basic way to learn all this kind of thing. Of course, you have to start with how does code works in Go? Like what is syntax? You know, what does Go routine means? You know, how does multi-threading works? What is struct means? All these kind of small things, right? But from my experience is I've mentored quite a few people in Android space before. What I find is if you spend a lot of time reading code, even without understanding anything, don't have to understand anything, just look at the code. You will see patterns on those code. That's why they have design patterns. You see pattern that this is how applications are being written. And once you see that kind of pattern, then you can apply using your own code. There's no such thing as reading and you can understand. You have to code. That's why a lot of people, they spend a lot of time in GitHub. I spend a lot of time in GitHub. I download a lot of source code. And I don't say that I understand everything, but from my point of view is if I look at code, I might see the pattern and I apply something on my own later on. That kind of thing. So it depends. That's what I can say.
Great question. All right. So we might wrap it up there. We'll let the folks on the live stream we'll wrap it up. So if you just want to say a goodbye to everybody on the live stream, or one person of them. Okay. This will be on. Quite quickly. So this is being live streamed out to YouTube, so you'll be able to find it on the golang-syd YouTube channel. So let's just